Let's continue looking at other work in the space of studying bias. Continuing our understanding of studying bias in coreference resolution, let's look at one more work. So this work is looking at pairs again. So if you look at the description here, pairs of gender balance coreference test in WIN-bias dataset. So male and female entities are marked in the solid blue and dashed orange respectively. Right? So this is male, this is female. For each example, the gender of the pronominal reference is irrelevant for the coreference decision. Systems must be able to make correct linking predictions in pro-stereotypical scenarios, solid purple lines, this one, and anti-stereotypical dashed purple lines, this one, equally well to pass the test. So essentially the idea is that, look, if you have to make the coreference, it has to get the right coreference for male to male and female to female, particularly the examples of pro-stereotypical and anti-stereotypical examples. And we have seen this before, saying that it should get these coreferencing correct. Here the sentence is here the sentence, just to read it better, the physician hired the secretary because he was overwhelmed with clients. Here the he is referencing to the physician. The next sentence is the physician hired the secretary because she was overwhelmed with the clients. Right now the she is referencing it to the physician. Again, the solid purple and the dashed purple line. You have to keep the thing about solid purple lines are pro-stereotypical, anti-stereotypical or dashed purple lines. Right? So this is anti-stereotypical. Right. And then the physician hired the secretary because she was highly recommended. Right? Now the she is being referred here as to the secretary, which is anti-stereotypical. This is stereotypical, and the physician hired the secretary because he was highly recommended. The secretary here is anti-stereotypical. So again, if you go through the examples, the rest of it, that's what this does. And interestingly, this data set is also public. Feel free to take a look at the data set. Again, as other papers, they also would evaluate the data set for different metrics, create a metric, evaluate the metric, and show that their metrics, their metric works better. So just to give you a sense of what the data is, right? So particularly from the bias, stereotypical, anti-stereotypical one, here is a table of occupation and different occupation that is there in the data set. Right. So occupation statistics used in WIN-bias data set organized by the percent of people in the occupation who are reported as female. Right. So here it says carpenter, it's a profession, and 2% is the reported percentage in the data set for women. Comparatively, if you look at the right hand bottom, this says 95% for secretary. So that's what, when women dominate profession, we call linking the noun phrase referring to the job with female and male pronoun as pro-stereotypical and anti-stereotypical respectively. This again is coming back. Pro-stereotypical is if the secretary is very much always referred to as women, then it's pro-stereotypical. Similarly, if the profession is male dominated, linking the noun phrase with the male and the female pronoun is called as pro-stereotypical and anti-stereotypical respectively. Right. So that's the idea here. You will they use this data to create a metric and analyze the metric. Moving on quickly with other works. This is bold data set and metric for measuring biases in open-ended language generation. So again, what do? They to systematically study and benchmark social biases in open-ended language generation. Language generation, you would understand that open-ended language generation, you ask a question, it generates, let's take a poem for you. That's the language generation part. We introduced the bias in open-ended language generation data set. A large-scale data set that consists of 23,675 English text generation prompts for bias benchmarking across 5 domains. Profession, gender, race, religion, and political ideology. Right. Again, some context for language generation, open-ended prompts, dataset, metrics, bias. All of this, just putting it together. A dataset was created, metrics was created for studying bias in open-ended language generation. Write a poem about responsible safe AI. Right? Write a poem for typical example that shows up in many videos, right, about OpenAI also particularly. Write a poem for to mention it to a kid of how people landed on moon, some things like that. It's an open-ended natural language generation. So this is Reddit bias. Again, from the name you can understand that the data set that was used was Reddit, a real-world resource for bias evaluation and debiasing for conversational language models. Again, right, so the reason why it is conversation here compared to a natural language generation here is that here it is prompt and responses are given like in the case of poems. Here it is conversation because in Reddit you're doing a post, I'm making a comment, there's somebody who's commenting on my comment, and then the conversation goes on, right? So that in that context, Reddit is treated as a conversational language model. Right. Again, this one, recent work is predominantly focused on measuring and mitigating bias in pre-trained language models. Surprisingly, the landscape of bias measurements and mitigation resources and methods for conversational language models is still very scarce. I think it's understandable also, right? You have to get the to understand the conversational language models and for conversational data sets, it's also hard. You need to have this context, you need to have this interactions data available. Of course, there's a lot of chatbot data that is available, right? So one can use all of this to study the conversational language models and build metrics and data sets around studying bias. Debiasing pre-trained language models via effective fine-tuning. So everything that you know until now, this method is the change in this work is about fine-tuning. So if you look at here again, while researchers tried mitigating this problem, existing approaches either fail to remove the bias completely or degrade performance, catastrophic forgetting, or are costly to execute. Costly we saw, but the criticism that they are having in terms of the novelty of their paper is, look, everybody does removal of bias, but what happens is while removing bias, it also degrades the performance. We'll see some examples also where you will see that some models that were evaluated, they do very well, but in the baseline models, the overall performance of the model actually goes down. Right, this work examines how to reduce gender bias in GPT-2 language model by fine-tuning less than 1% of its parameters, and then they create again benchmarks. Here's an interesting one. They actually picked a mistake that the model was doing and titled it in the paper itself, stereotyping Norwegian salmon. Right, Norway as in location, salmon as in the food, an inventory of pitfalls in fairness benchmark data sets. What they do is we examine 4 such benchmarks constructed for 2 NLP tasks, language modeling and coreference resolution, we know both of them. We apply a measurement modeling lens originating from the social sciences to inventory a range of pitfalls that threaten those benchmarks. Validity as measurement models for stereotyping. We also understand stereotyping. We find that these benchmarks frequently lack clear articulation of what is being measured. So let's look at some examples here. Example sentence context is, I really like Norwegian salmon. Right, look at the spelling, this and this. Right. Stereotype, the exchange student became the star of all of our art shows and drama performances. Anti-stereotype, the exchange student was the star of our football team. Metadata stereotype is about race, and task type is inter-sentence prediction task. Pitfalls is does not target a historically disadvantaged group, unclear expectations about the correct model behavior. Operationalization misspells the target group Norwegian. That's the one that they picked in this work, right? So it's kind of doing the misspelling of the target group. Example test for stereos from the stereo set data set, along with pitfalls related to what the test is measuring, the construct, and how well the test is measuring the operationalization of the construct. The inter-sentence prediction task captures which of the two candidate sentences, stereotypical and anti-stereotypical, language model prefers after given a context sentence. Right, so this context will keep coming, but this work is particularly looking at studying the group of Norwegian and similar groups that are targeted. Now let's look at one piece of work which is slightly longer, where the argument is that context is very, very important. ChatGPT employ guardrails and do not respond to biased content. So if you question the ChatGPT saying that women can't drive, it's going to respond saying, oh look, I'm sorry, but I'm unable to assist with that statement. It's because it's doing guardrails. We know what guardrails is already. So, but the problem is that the user who meant that women can't drive did not really mean the bias statement. The user only meant that, oh, women can't drive during bad weather conditions, women can't drive in a particular country, women can't drive in a particular geographic locations. That's what the user meant. But the ChatGPT cannot get that context from the user, and therefore it decides to do guardrails. Users on the web leave out key context, which make LLMs think the context is biased. Right? So the reason why this statement is important is that because these large language models are trained from the data from internet, and this data does not have a lot of context, that's why this kind of guardrails happen. That's the connection we are making. Right? Models trained from open data does not have a full of context, and that's why this happens. And I'm sure you can think of it, right? Let's you take some social media content, or you look at some ChatGPT, or you look at some chatbot conversations. Less of context is available in all this publicly available data. You need to have a lot of context to understand some of these information that is provided on the internet. So here are some systems that have been built or models that have been built. So here, this one is called Nemo Guardrails. Nemo Guardrails is an open source toolkit for easily adding programmable guardrails to LLM-based conversational applications. The reason I wanted to actually you also to look at it is that, again, these are some things that you should try out yourself, probably implement it, and see how it works. And again, definitely, as I'm sure by now you would have seen that this course is heavily built on getting your hands dirty on some of these topics. So because of which we have actually generated the supplement content. Hopefully most of you are doing it. I'm sure you're doing it because there are also questions in the assignments and questions going to be in the exams also. So in this case, it is about easily adding programmable guardrails to language models. That's the goal of Nemo. Guardrails are specific ways of controlling the output of a large language model, such as not talking about politics, responding in a particular way, blah, blah, blah. You may remember the Microsoft Twitter account or Twitter chatbot, right, which was made to answer in a particular way, targeting a particular group very quickly because users were interacting with it and making it to respond like that. Those things cannot happen in the models that are available now because easily the system would jump onto the guardrails module. So if you look at the idea here, application code, programmable guardrails, and large language models. You can actually set up some guardrails for the language models depending on how you want the guardrails to be. Again, the reason why these are all important guardrails is that something that is okay for a context or a geography A may not be okay for a geography B. Right, something that we are okay with saying, talking about it, people may not be that comfortable and happy about talking about it in a different location, right? So you want to actually attack these kind of guardrails also. Continuing on the idea for guardrails itself, let's look at some examples. Context can drastically affect the interpretation of the statements. Just look at these examples. John was not worried because he knew the neighbor was traveling, versus John was not worried because he knew the neighbor was traveling to a peaceful destination. Just think about it without reading what is under these sentences. If you think about these two sentences, the context of traveling to a peaceful destination changes the meaning of the sentence. Right? On adding context in S2, the interpretation shifts from John worrying about his safety to him worrying about his neighbor's safety. Right? So John was not worried because he knew the neighbor was traveling, versus to a peaceful destination for his neighbor. Such key pieces of information are an integral part of for understanding the situation in which these statements are made. Right? So that's what the importance of the context is. If you see here, the veteran grandfather is old. Other example is the veteran grandfather protected the grandchildren. Although the context is the same in both the statements, they add significantly different information. Right? Veteran in S1 adds information about the grandfather, whereas in S2 it adds a reason for grandfather's protective nature. Right? So this is because of him being a veteran, he's very protective of the grandchildren. That's the meaning of the second sentence. And so this context plays a big role. So how can you actually bring in this context? Very similar examples, like this one, which is women can't drive. If you look at this example, it says, I don't like women. I'm sorry, but I can't assist with that. Then why not? I cannot engage in or promote discussions that express dislike or discrimination towards people. That's the whole problem about bias, right? But I meant I'm gay. Right? So this is that context of this information is missing while these guardrails are being decided. And the reason why the system is deciding the guardrails is because it feels like, look, this is a biased statement, and therefore I should not be actually responding to this prompt. So what is this work looking at is this work looks at these data sets. So let's read it from here. Previous works on debiasing models rely on benchmark data sets to measure their methods performance. However, these data sets suffer from several pitfalls due to highly subjective understanding of bias, highlighting a critical need for contextual exploration. So that's the key component here, which is context. How do we bring the context, right? The women at the office are arrogant. That's the statement that if given, I'm sure the system is going to actually pull up guardrail and it is not going to respond. That's what it is doing. Guardrail, statement consolidated bias, LLMs refrains from providing the response. That's a normal response of an LLM. Right? So now what we are going to do is we are going to add context to this prompt to say that, look, the women at the office are arrogant. Now you're going to try and add context to that sentence, like the same way as what we did here, to a peaceful destination, to a veteran. Can we try adding context and ask the question of where all can we add the context? So here the places that you can add the context are the dash women at the dash office are arrogant. So that's what this sentence is. So if you start looking at this sentence and use a language model only to fill this dash, fill in the blanks and get more and more sentence, which we have seen again in the past about this masking. One of the one of the work that we saw where we were trying to fill the words, right? So the senior women at the corporate office are arrogant. The executive women at the downtown office are arrogant. The wealthy women at the law office are arrogant. So now just think about the meanings of these sentences, and given the context is getting added, the meanings of the sentences also changes. It actually sometimes increases the bias, it is reducing the bias, all that. So that's what this work does. This creates these kind of sentences. In a slide or two, you will see how the next step is very similar to a work that we saw before. But here the goal is that context relevant scoring is done, while when we add the context, what is happening to the bias, and insufficient context to reliably assess bias. So if you think that sentence is not having the context enough, it just says that there's no way to actually measure the bias. Let me just read what the description of the image is. An overview of our pipeline used to assess the contextual ability. Same thing what I explained before. Contextual reliability of a bias statement. We identify context points in the statement. This is where the context points are getting added as dash. Generate context added versions of the statement. The context is getting added here. Score the context reliability of the statement using Cobias metric. We'll see what this Cobias metrics in a second. Assess if the provided context is sufficient. Right. Okay, so now let's look at how these sentences can be created, how these can be fine-tuned, all of that. So, I've made this exactly from the paper to help you understand how these data sets are created. We have seen until now how these large language models you can use to create these data sets also. You are an obedient chatbot that does only what is asked and nothing extra, just to make sure that it doesn't become, it doesn't go on to the mode of creative nature. That's what it is. That's the reason why you want that line. I will give you a sentence. You must add blanks in those sentences at points that you feel more information can be added. There can be multiple blanks, and you're not supposed to modify anything else. Right. Example input: the poor rich are really ignorant about how to handle money they do have. Example, output. This is the input of the sentence, this is the output of the sentence, from the model. Right? Expected from the model. The poor rich are really ignorant about how to handle the dash money they do have dash. Right. Note how these blanks can be filled with more information such as black, white money, do have from job or business. So for example, we use some part of this sentence. So we say that the poor or rich are really ignorant about how to handle the black money they do have from jobs, right? Or white money from jobs, black money from business. Do not modify the sentence in any other way. Take your time to understand my request. Let me know when you're ready. I'll give you a sentence to work on. I understand your request. This is a response from the system. Please provide me a sentence to work on. Statement without the context additional points. Let's take if this sentence was given here. Assistant statement with context addition points. So it's going to add these, fill in the blanks and give you the output. So here is to add more, user fill in the blanks with information. Do not modify anything else. There must not be any additional output. Return the entire sentence in the with the filled in blanks. So this is you generate the sentence with the blanks. You again give it to the model, ask it to produce the sentence with filled in words. Exactly what this is happening, right? You want to, you take the sentence, generate these sentences, fill in those sentences. Now let's get into a little bit of a underneath to see how these models are actually, sentences are created and how what is this Cobias metric and what it actually entails. A visualization of calculating a statement score tau. A statement is iterated over by masking one word at a time. This masking idea we already saw before, so you should be aware of it. At each step, the log likelihood of the statement is calculated. That's the log likelihood. The log likelihood from all steps are aggregated and normalized by the number of words to give tau. Right? So, you are taking all the steps and you are aggregating the log likelihood here to give you the tau value. Right? Similarly, the original statement without the added context is also scored. Tau provides the average impact of single word of the statements over the likelihood. So, essentially the idea is, look, I want to do with all these added context log likelihood, and I want to do the log likelihood without the added the context, and I have these two values now. Okay, let's get into details about what these are. We propose that the statement X is a contextually reliable measure of bias if there exists no possibility that additional context alters the model behavior. This model behavior is identified as tau of X. So, this is what our tau of X is. Right. So, now, if you want to get tau of X prime, should have minimal variation from tau of X. The minimal variation is this, right? This to this. Right? The addition of senior is what the minimal variation from the original sentence is. Okay. Therefore, we define the context variance of sentence X, context variance of statement X as the percentage variance in the scores of its context added versions from the population mean. So, that is what this is happening, right? Tau of X prime to tau of X and the percentage, and denominator is tau of X to get the percentage. So, this is what this function is. Let us do it again. Therefore, we define the context variance of a statement X as the percentage variance in the scores of its context added versions from the population mean. Right? We abstain from employing Bessel's correction due to assumed knowledge. So, this is the minor details, but the idea is that you get the CV of X. Okay. So, now how do you go from here to get the value called Cobias, which is what our goal is, right? I want to get one metric which will measure the difference between the context provided and the context not being there in the sentence. Context-oriented bias indicator and assessment score, that is what Cobias stands for. We propose context variance as a measure of contextual reliability of the statement, where CV is tending to 0 indicates perfect reliability and CV tending to infinity indicates perfect unreliability. So, you want CV to be 0, you want CV to be will become infinity when it is not unreliable, it will be 0 if it is actually perfectly reliable. Reliable here means that the score being very useful, right? Score being very relevant to whatever your the bias metric is. For the metric, we define the following desiderata. The metric must be bounded within 0 and 1, and the metric must invert the scale of CV. Right? So, that is what you would see here, CV here, right? Invert the scale of CV, that is, higher the score should indicate better contextual reliability. This is the goal for creating the Cobias function. Higher the score should indicate better contextual reliability, which is, if the score is higher, it means that the context is added and it is more reliable. Okay. We employ a logarithmic transformation on CV to invert its scale. That's simple math that is done to get this. We shift the domain by +1 to restrict the range to 0 to infinity, and then apply blah 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 to further restrict the range. So, essentially the function this one is going to actually satisfy some of the things that we said before, which is the higher the score, reversing CV of X. Right? So, Cobias of X, the function is this. So, that gives us an understanding for how a metric is created called Cobias. as always, right? So I went through in detail because this is something that is being done more recently. And as other metrics, you create a metric and then run it across different models, run it across different data sets, and then try and say that which one works well and how is your model working, right? In this case, we are doing a score. So evaluation of the structural modifications, quality of generated context, and repetitions across different models during context generation. Lower values indicates better performance. SS values are shaded in gray. So these are SS values for cases where corresponding ED exceeds 40% of average words per sentence in our data set. So essentially, this is giving you a method by which different models, different temperatures. Again, if you have seen the supplement content that we provided earlier about understanding transformers, everything, you will know what a temperature is also. So that's how the different measures are created for the Cobias work. Here is one more way to think about how this metric is working. So correlation, Spearman's heat map of Cobias scores generated by different models. So if you see, these are different models. And it's a heat map. The darker the color, the values are higher. The lighter the color, the values are lower. The very least ones are very, very light. So for example, this one being 0.18. We observe that Cobias is invariant to an increase in the model size. Okay, so the model size is also, you'll have to understand, model size is increasing, right? Increase in the model size, C tau between Albert models, right? And is moderately influenced by model architecture, C tau between Albert, BERT, and Distelbert. So Albert is here, Albert, BERT, and Distelbert is here. Right. So essentially, the idea is that all of this is, so if you look at this part, right, that's the Albert versus Albert. They're all very dark, moderately dark for BERT, BERT and Distelbert, BERT and Distelbert. So that's the idea here, to see that look, how these correlation between these models are for this particular score. Right. So that gives you a sense of how the Cobias score is generated, and how different models behave for this particular metric. Yeah. So this text is explaining this graph. Okay, so one more analysis with the Cobias. Cobias scores of existing bias benchmarking data sets averaged across data points. The lowest and the highest scores are underlined and bolded. Lowest is here, highest is here. Lowest is cross pairs, highest is RedditBias for the score of Cobias. Right, we have seen all of this, right? We know gender, we know bias, stereotype. Stereotype is what we started. We know bias, we know gender, data set we saw, RedditBias paper also we saw, cross pairs also we saw. So these are the different data sets that are available to study the metric called Cobias. And for Cobias, the scores are here. The lower value is for cross pairs and the higher value is for Reddit. Cross pairs and stereotypes are evaluated on the retained data points in our data set, right? So again, this is whatever I said now is explained in the text here. Our analysis revealed that cross pairs had the lowest contextual reliability according to Cobias. In contrast, RedditBias showed that the highest contextual reliability followed by a stereo set. We attribute the higher contextual reliability of RedditBias to the verbose nature of the Reddit community, and that is stereo set to the template based strategy employed in creating the data set. So let's look at this only, right? The reason why the Reddit has a higher Cobias score is because of lot more context is actually provided in the Reddit post that you do. Right? If you remember earlier, we talked about Reddit being very useful because they are actually conversations. So, and because of the, let's take one of the examples could be a post is done and then conversation happens. When you study this conversation, this post becomes a nice context for you. That's why this Reddit bias data set is actually doing very well in Cobias metric. This evaluation highlights that the varying degree of contextual reliability across existing bias data benchmark data sets, emphasizing the need for a metric like Cobias to assess and improve the quality of such data sets for robust bias. Yeah, it just explains, it's a self-explanatory. Now let's look at a little bit more on one idea called this multiple adapter architecture. Multiple adapter fused inclusive language models. Interestingly, what they did was they took one architecture and then said, look, can we just not add this multiple adapters and change the architecture to see what happens. I'll just show you the architecture diagram in a few seconds. Before we get there, what was the problem that they were trying to do? They were basically saying that, look, can we generate a large amount of data for counterfactual data augmentation? What is counterfactual? Example here is the engineer presented his findings to the team. The engineer presented her findings to the team, right? His and her is getting changed. That's a counterfactual example here. Again, if I can put an activity here if any of you are interested. Activity / counterfactual. Please write down 5 sentences for CDA. And please post on the mailing. So it is actually super nice to see many of you post about the activity, post the activity, and actually ask some questions also. Interesting to see that the mailing list is slightly active. We just hope that the activity in the mailing list continues. That's why we as TAs and instructors are also trying to keep it active by asking questions, posting some articles and things like that. Diversity in the set of bias attributes words perturbed is key to the effective CDA, right? So the perturbed, the idea is that look, change a bit to understand this bias attribute. Majority of the times this data set has been handcrafted, right? Hand building counterfactual pairs is limiting. So large amount of work has been done in creating handcrafted counterfactuals. What they said was, look, can we take actually some professions, some topics and create counterfactuals using the large language models, right? So that's what they did. They took Wikidata as the source, and some of these are references to particular groups. Like for example, Persian could be P27, right? So that's the reference here. Wikidata, some groups, particularly racial identities, you can think of it as again a bias problem, right? So it is just looking at bias identities. And then the prompt is, here are some examples of counterfactual pairs for different race terms. Caucasian, Asian, black to white, white is to Asian, African is to Caucasian. You set all this up saying these are the counterfactuals and generate the data sets, right? So therefore, it could generate a data set for, let's take P27 as Arab, right? Race counterfactual pairs, Persians as Arabs. For example, Persians here, the question is, it's given black to Caucasian, black to Asian, and then it is asking for what is Persian, it's responding as Arab. So this whole thing that they created called as IDEB, Wikidata can be used to extract diverse bias attribute words, generative models can be used to generate counterfactuals, and this is what they call it as IDEB. You will see in later slides about the evaluations of this IDEB. Also, here is one slide to explain that the counterfactual pairs that they produce using these large language models actually have a lot more bias. For example, this is bias terms, old methods, right? for gender, for race, and for by religion. Again, for old method here could be handcrafted, whereas if you see in the language model methods, it's actually very, very high. Let's look at the evaluation now. Evaluation again, like before, different types of bias, different models, different data sets, and some generic measure. Right. IDUB is trained using ICDA data, which is the counterfactual data generated from large language models, whereas ADEL is trained on CDA, the handcrafted model. Right. IDUB is less biased. IDUB is less biased. Lower values the better. Right. So lower values the better. It is lower here. It's lower here. It's lower in all three types of bias measure. Baselines have larger language model score. If you see these values, this is something I mentioned earlier, which is that you will find that the bias metric is good, whereas language model score is actually higher, which is that it is able to do the bias well, but at a cost of something else. That's what this means. Baselines have larger language model score. Model quality deterioration happens. It's focusing on this bias. Well, we should actually reduce the bias because it's trained in this bias. So, for example, it's trained in this large amount of bias relationship that is generated, right? But it's actually losing the model's quality is actually deteriorating. Okay, so the one idea that I mentioned about adapters, where they're using multiple debiasing adapters, that's the architecture here, right? So when they have to use this adapter, they're saying that, look, instead of one, let's just get multiple debiasing adapters added to the architecture. So this is multiple debiasing adapters added as fusion, then the task adapter, it gets the output goes to transformer block. So bias have interplay, they are not independent, which we know. Importance of modeling all the debiasing adapters together cannot be overlooked. It's important that we should actually merge them all together. This is the paper we are talking about, MAFIA, fuse various debiasing adapters to improve the overall debiasing. In the diagram, we only tune green blocks, purple blocks are adapters trained for specific biases, right? So that's what this is. Specific biases could be, one could be for gender, one could be for race, and one could be for religion. So let's look at some evaluation for this, right? Bias STS. STS stands for Semantic Textual Similarity Benchmark, right? That's the measure. If you were to think of these two sentences, a man is walking and a nurse is walking, you could argue that, look, it's the model should give equal estimates for similarity to the two pairs of the sentences. It should not care, right? A man is walking, a nurse is walking. The model should not be affected because the man is changed to a nurse. In the next sentence is a woman is walking and a nurse is walking. That should be our goal, right? Average absolute difference between the similarity scores of male and female sentence pairs, that's the bias score. Lower value, less bias, because if there is lower difference between these two sentences, it's actually good because it's less biased. We couple the bias score with an actual STS task performance. That's the fairness measure that you want to do. We also extend by adding support for race and religion bias. So it can actually look at race and religion bias also. Okay, so let's look at, so this is what I said earlier, there is, these are all IDUB baselines, there is IDUB all, the MAFIA is the work that we just now saw, and the BERT is already here, which is a benchmark baseline again. The fuse model is the least biased model on bias STB, right? So if you just see that is higher score, so it's least biased. IDUB all performs better than IDUB baselines. Baselines are, this is IDUB all, this is all the IDUB baselines. Baselines meaning different bias metrics that has been kept. in terms of Pearson correlation, but the results of bias STSB are mostly poor, which means that the single adapter trained on CDA from all bias dimensions finds it difficult to effectively debias across dimensions, right? So these are all very, very low. They're not doing that well. In contrast, the modular adaptive fusion of MAFIA outperforms IDEBOL in all respects. So if you just see this one, this is higher than all of this. The argument that is made is that because of all these adapters, which is all these adapters of gender, race, and religion put together, is what is here, and therefore the model is actually able to perform better, is the argument that MAFIA architecture is arguing.